What's going on, guys? We're gonna get this final exam review going. You guys will get that today. Do your best, follow along. I would pause it, maybe do your own problems first, and then kind of see what I'm doing. See if there's anything that you can do differently to prepare. Go over your module notes. Hopefully you guys feel good about your old exams, your old quizzes. So hopefully this helps. If you guys need anything, let me know. All right, so here is the trig review. I'm gonna do my best to go through as much as I can. I will say that going over your module notes is probably the more comprehensive way to go over this stuff. So some of it will be multiple choice, some will be short answer. Either way, you still gotta know what you're doing. So translating a graph. Now, we know that this would be a concave down parabola because A is a -1. So it would look something like this, but that's not the question. How do we translate it to produce the graph of y equals -x² + 1? Now, I know that is a vertical shift up because that's that plus k value, so it's going to be up 1 unit. So that's the answer, up 1 unit. Vertical 1 unit, it's a vertical shift, that's the k. What is the transformation of the cubic function that yields this? Okay, so this is a lot going on. So first, I'll break it down the shifts. So on the inside, we have an x + 7. That tells me it's a left shift 7, left 7 units. That's a k shift, so that's going to be down 4. So that's the shifting. Now this -1/3 for the a. So negative means it's going to be reflected, and 1/3 means that it is going to be compressed. So all the values you would get out would be a third less than normal. So I think you should you're gonna take your cubic function. It's going to be reflected, so it's going to look something like this, but then instead of looking like that, which is a normal, a being 1, it's going to be spread out quite a bit. So it's going to look something like this. This is not exact science. I Desmos to check it or make a table and plot on a graph, but there you go. Number 3, domain and range. Domain is all of the x values that the graph can exist on, and range is all of the y values that your function can exist on. Name the intervals where the function is increasing and decreasing. So we have a couple things to do here. So first of all, I notice that my lowest x value appears to be -6. This is a continuous function, and it looks like my highest x value is 4. So I like setting it up like this because it just gives me a visual of the domain. So you could write this in inequality notation, saying that domain exists everywhere in between -6 and 4, or you could use set notation, or interval notation, not set notation, and say that it exists from -6 to 4. So any x value in that area could have a point. The range corresponds to the y values. And this graph's a little hard to see, but I'm gonna say this is a -2, and I'm gonna say that is a 3. So then the range would be from all the y values that exist from -2 to 3, or you could write it as -2, 4 using hard brackets, not 4, 3, using hard brackets to denote that you two touch the points because these are closed circles. Increasing, we are increasing from here to here. So let's see, that's from -6 to, let's call it -4. We are also increasing from, looks like -1 to about 3. Increasing, the graph is moving up. Decreasing from -4 to -1. And from 3 to 4, I think this really should have been a 2. 2 to 4. So that's domain and range, increasing, decreasing, intervals. So let's pause for a second. All right, so finding the inverse Usually this is presented f of x, but since it's not, a little a little simpler. So we're going to swap around x and y. So we get x equals 2y plus 10. Now you just got to solve for y. Subtract 10 on both sides. Divide by 2 on both sides. And then all we got to do is say y equals x minus 10 over 2. We can write it as the inverse of the function equals, you could leave it like that, or go ahead and do x over 2 minus 5. This is the inverse of 2x plus 10. That is the inverse of 2x plus 10. X and y intercepts. It's where the graph, your function, crosses the x-axis, y-axis. This function has 2 x-intercepts and 1 y-intercept. The x-intercepts exist at -3, 0 and -1, 0. The y-intercept exists when x is 0. So that's going to be at 0, -1. That's your x and y-intercept. Let's see what we got next. If you have any questions, make sure you comment down below. Hit me up. I can make more videos, go more in depth if that's what we need now. What is the vertex? A vertex is the peak or the valley. It's a max or a min value. In this case, it's a maximum, and it exists at -5, 4. So the max value of this function is 4. The max value is 4. That's the absolute max for this function. Number 7, looks like we have a quadratic to solve. I'm gonna take the square root of both sides. I'm gonna rewrite it. We know we have lots of tools to solve quadratics. Take the square root of both sides. So I'm gonna get 6x minus 5 equals plus or minus the square root of 55. That's a messy square root, can't really simplify it. Solve. Plus 5 on both sides, go up top. 6x equals 5 plus or minus the square root of 55. We'll divide all that by 6. So x equals 5 plus or minus the square root of 55 over 6. So messy, you could definitely decimal that out. I'm not gonna do that right now. This one, this is a quadratic, looks kind of messy to me. I'm gonna solve to get this equal to 0 just by adding both of these to the left side. So if I rewrite it, I get 25x squared plus 80x minus 57. I could divide. I think I'm just going to go straight up in quadratic formula this one. So the quadratic formula, it always works when you need to solve a quadratic no matter what. And the way I remember it is a song, so it's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. That works as long as you know what a, b, and c are, which I'm going to label. A, b, c, plug them in, do the math. So when you do this, you want to check your discriminant. That's going to tell you the type of solutions you're going to have. So we're going to get -80 plus or minus the square root of 80 squared, which is going to be a large number, minus 4 times 25 times -57. Handy dandy calculator is not nearby, so I'll be right back. All right, rectangular garden. Whenever I have something like this, area, perimeter, whatever, I'm going to draw a picture just to help me out. So I need to find the area. I don't know the area. I know the length. It's going to be 5a plus 10. And I know the width, which is 5a. So there's really nothing complicated in here. This is just multiplication because, you know, the area formula is length times width. So can you multiply polynomials? So 5a times 5a plus 10. Good old distributive property. We're going to get 25a squared plus 50a. That's the area. Now, that doesn't really do a lot for us because we don't know what a is yet. Oh, square feet too. Feet squared. Square area is always squared, but there you go. Down here, same thing. Double distributive property. Multiply the 7. 14 minus 7i. So this is complex numbers now. And then on the bottom, you get 6i plus 6i minus 3i squared. You got to know your powers of I. You know that I squared simplifies to -1. So this is really going to be 14 minus I plus 3, because you would get -1 times -3, which turns into 17 minus I, and that is your complex number. Again, complex numbers, real part, imaginary part. When it's adding or subtracting, just combining like terms, CLT. So we got those guys, we got these guys, we got 17 minus 5i. That's just combining like terms. It's 13 again, combining like terms. Now with the subtraction, what I like to do is I like to rewrite it, because you're really distributing the negative sign. I don't like subtracting. I just like adding positive and negative numbers. And now we're gonna do the same thing we just did, combine your like terms. So find your constants, find your imaginary numbers, put them all together to get the complex number, and you get -2 plus 13i. It's really not that complex, guys. It's pretty simple. Okay, 14. We got a lot of reading to do. So solve a quadratic equation by completing the square over the set of complex numbers. So that's telling us that we're probably going to get an I. Show your work. All right, so first, completing the square, you got to make sure that A is equal to 1, which it is, and that it's equal to 0. So I'm going to bounce that 40 over it. I'm going to add 40 to both sides. So we're going to get x squared plus 22x. Actually, I'm just going to put that over there. Plus or minus, sorry, whoa, plus a blank. Subtract 220 on both sides. So it's going to be -260 plus whatever I'm going to add. Now you add the c, or the constant, is going to be b, so 22 divided by 2 squared. So that's going to be 11 squared, which is 121. And you're doing that because you want to make a perfect square binomial on the left-hand side, which this is going to be x plus 11 squared if you don't. All right, so I don't know what happened here, but I seem to lose some video somewhere, so we're just going to have to start here. Everything's there, but I'll get a note card out and we'll just do it quickly together. So rectangular garden, draw a picture. Area equals length times width. You got to find that. We don't know it. You know that's 5a plus 10, length and width. And then you just multiply by distributing. So 5a times 5a plus 10. Distribute that guy, you get 25a squared plus 50a feet squared. We don't know what a is, so we don't know the exact number, but that's how you do 10. The back side, 11, similar, we're distributing, but we're distributing with complex numbers, so you just have to remember your powers of I. So you're going to get 7 minus 3, or plus 3i, times 2 minus I, and all you got to do is distribute the first term and then distribute the second term. Make sure you remember the powers of I. You get 14, and then we get minus 7i, then we get plus 6i, and we get minus 3i squared. 3i squared, I squared simplifies to -1. So when I combine these, I'm going to get 14 minus I. That's going to become positive 3 because it's going to be -3 times -1. And that's how you get the 17 minus I. 17 minus I. For 12 and 13, it's just combining like terms. That's it. Combine the constants, combine the imaginary numbers, put them together to get your complex. I don't like subtracting, so I would always turn my subtractings into addition problems with negative numbers. All right, and now we're down to 14, which 14's got a lot of reading. So it's completing the square. To do that, you want to make sure that you have the constant pushed over to the other side. So I subtracted 220. Then you got to look at the middle term, your b value, divide it by 2, square it. That's the constant you add to both sides. So we're going to add 121 to both sides, and that helps you get a perfect square trinomial, well, binomial, on the left-hand side, which is x plus 11 squared, which we got. And that's going to equal, I should be able to do my head, but my brain's kind of stuck right now. So 260 and 121 is going to get us a -139. And that's where that whole imaginary number piece comes in, because square root of a negative number is messy. Take square root of both sides. You get x plus 11 equals plus or minus the square root of 139. Now, I'm pretty sure 139 is ugly. Can 139, does 13 go into it? Does 3 go in, does 9 go into it? I can't think of nothing. So we're just gonna leave it like that, square root of 39. So what this is gonna become is x plus 11. Sorry, let's subtract that 11 right away. So it's gonna be x equals negative 11, and then here's the imaginary part, plus or minus 139i. Now, obviously, this wouldn't get graphed on a normal plane. You have to get into the imaginary plane, but that's what you would get. So you'd have the two answers. You do negative 11 plus and negative 11 minus, and that's your two solutions, the two roots. All right, so now that we have the absolute value part isolated, we're going to rewrite this into two equations. So it's going to be 4x minus 5 equals 8, and 4x minus 5 equals, this pen gets me a little messy, negative 8. So now you're going to solve this for both values of x. So add 5 on both sides. You're going to get 4x minus 5 equals 13. Nope, 4x equals 13. And 4x equals negative 3. Division property of equality. Divide by 4 on both sides. And you get x equals 13 over 4, which is a little more than 3. And x equals negative 3/4. Those are your two solutions to that absolute value equation. Without using technology, let's graph this parent graph and then translate it. So parent graph of absolute value, there's no negative value, so you get your vertex at 0, 0. You put a 1 in, you get a 1. You put a negative 1 in, you get a negative 1. You put a 2 in, you get a 2, etc., etc., etc. Now, the translation. Well, I see that I've shifted it down 5, so my vertex is now going to be there. Oh, I shouldn't have marked that yet because I didn't look at the horizontal shift yet. And I'm also shifting it to the right 3. So in actuality, my new vertex right there. Now, I didn't change anything about my A value, B value, so the graph's going to look exactly the same points, 1, 1, 2, 2, 3, 3. Let's see, I can use this. Make nice straight lines. Always use a ruler if possible. Arrows at the end to continue it. Now these lines should be parallel. So we shifted down and to the right. Horizontal shift to the right because it's in the opposite sign of that negative, and verticals tell you exactly what they mean, and you go down 5. So this is the parent. That's what all absolute value equations stem from, and this is our translated version. All right, write the equation of the circle in standard form. So this is where we get to have a little fun and do the double completing the square. So completing the square, guys, you just got to take your time. So we're going to have x squared, and we're going to regroup the x terms, and I'm going to automatically set it up. So that's my x terms, and then I'm going to put my y terms together. We get y squared plus 10y. I'm a little stuffy. I don't know if you guys can tell. Plus, and then plus 18 equals 0. So I'm going to complete the square. Let's see. If I take negative, oh, sorry. I wasn't showing you guys what I did. If I take the negative 6 and divide it by 2, I get negative 3 squared. You get 9. So I'm going to be adding 9. Over here, I'm going to be adding 25 because you're going to take 10 divided by 2, square it. So then I got to add that on both sides. So I ran out of room. I'm going to rewrite everything. So it's going to be x squared minus 6x plus 9 plus y squared plus 10y plus 25 plus 18 equals, now I got to add 9 and 25 to the right-hand side. That's going to give me 34. I do need to subtract this 18 on both sides, and I need to rewrite these trinomials as perfect square binomials to get it in the standard form of the circle. So the perfect square binomial that comes from this would be x minus 3 squared. And if you don't trust that, please do the math. Y squared, we'll do y plus 5 squared equals 16. 16 is a nice perfect square, which is going to help. So this is what we need, but our radius is not 16. It's the square root of 16, which is 4. And the center is going to be positive 3, negative 5. 3, negative 5, your h and your k. So you could take that and come over here and graph. So I would use a compass when graphing. I'll have to run and grab one. So radius 4. So 1, 2, 3, 4. Go 4 in every direction. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 1. That's 4. I'll sketch this. I would not sketch this. I would use a compass, but I want to get this done for you guys. So complete the square 2 times. Keep yourself organized. Perfect square binomials. Get your radius. Get your center. Graph circles. Done. Simplifying I to the 26. So I like doing this. What's 26 divided by 4? Well, that's 6 with the remainder 2. So that means this is going to be 1. 6 times 1. It's I to the 4th 6 times. That's just 1. And then r squared means that we have a remainder of r of 2. So that's I squared, which is negative 1. So this is negative 1. I to the 26th is negative 1. So I like to make as many groups as 4 as I can and then look at the remainder to tell me what to do. Identifying the functions. Now this is going to be hard for you to see, so let me pause this and I'll trace it. Well, this is obviously cubic. That's y equals x cubed, but we got to ask ourselves, was it transformed or not? Looks like it was shifted to the right 3, so that's going to look like this. Y equals x minus 3 cubed. Horizontal shifts are inside the parentheses. This is a parabola generated from the parent function y equals x squared, quadratic. But it's concave down. It makes a frown. It's not concave up. It doesn't make a cup. So that tells me that the a value is negative. So y equals negative x squared. This v-shaped equation is an absolute value equation that has been shifted. So absolute value looks like this, but it's been shifted to the right and to the, it's been shifted vertically, to the right and down. So we're gonna get y equals, to the right would be a subtracting, and looks like the new vertex is 4 comma negative 2, so it's gonna be a shift to the right of 4 and a shift down of 2. That's how you shift that absolute value function. This is the square root function. So y equals the square root of x. Looks like it was shifted to the left and down. And the new starting point is negative 6, negative 8. So let's use that. So we get y equals the square root of x minus 6, and we're going to also shift it down 8. There you go. All right, we need to factor completely. Since these are all divisible by 2, let's divide by 2 right away. We're going to get x squared, or you can pull a 2 out. Either way, so like this. 2 times x squared plus 18x plus 81. You should right away be seeing the pattern. 9 times 9 equals 81. 9 plus 9 equals 18. So we're going to get x plus 9 squared. It's going to be a double root. So you set that equals 0. X plus 9 equals 0. Take square root of both sides. You get x equals negative 9. The other way to do it would be to write it out and split this. But either way, you're going to get the double root. So the discriminant for this one would be 0 because it's just one root. So this would look like something like this. Because it's got a positive a value. Something like that. Just a sketch. That's what a double root means. All right. Given a function, identify its components, the domain, the range. See what else we can find. Well, domain is left to right, and the lowest x value is negative 4. The highest x value that the graph exists is 2. You don't look at the whole window because this is just a zoomed in part. You can zoom it out. So we get domain is negative 4 comma 2. If you like inequalities, well, you do both, but If you like inequalities, go -4 is less than or equal to x is less than or equal to 2, because those are closed circles. The range, you do the same way. The lowest value is -4. The highest is 4, so it exists from -4 to 4. So we're going to get -4, comma 4, or you could write it with inequalities and say -4 is less than or equal to y is less than or equal to 4, because y could be anywhere in there. Increasing, where is this graph going up? And that is over here. This is the increasing part. From 0 to 2, you only care about the x values for that. 0 to 2, 0 to 2. Decreasing is obviously from -4 to 0, and this is where you get that inflection point, your vertex in this case, and your minimum. So it's from -4 to 0, it's going down, it is decreasing. X-intercept, where does this graph cross the x-axis? Right about there. It looks like it's about -2.8. Oh, that's the x. So -2.8, comma 0. When y is 0, that's where you get your x-intercepts. The y-intercept is right there at the vertex, which is 0, comma -4. Your maximum value is right here. This is your max. And you would put 4. If you want to put the point, it would be at -4, 4. But for value, you care about the y, not the x. And the minimum is at your vertex, your y-intercept, which should be -4 at 0, -4. Every graph that you see, you should be looking for these things, even if you're not going to write them out. Part of being a mathematician is just evaluating the situation, and domain and range, all these components tell you a lot about your functions. End behavior. Well, in this case, it kind of stops. A lot of times we talk about end behavior in like graphs that continue on to infinity. The parent function is quadratic, right? It's y equals x squared. End behavior though, so I would say as x approaches x approaches 2, y approaches -2, and you could do the same thing over here. As x approaches -4, y approaches 4. But again, typically end behavior, we talk about, functions that are trending toward infinity. All right, last two problems. We got some right triangle trig. So we need to find the ratios of sine, cotangent, and secant. Cotangent is the inverse of tangent. Secant is the inverse of cosine. We are given from this theta, this is our reference angle, a right triangle. We are given the opposite side and the hypotenuse. So that's not a lot of room. So I'm going to go over here. Sine of theta equals 2 times the square root of 5 over 8. I could reduce that and get the square root of 5 over 4. That works for me. That's my ratio. This should have been a little more in-depth of a question, but it's not. But hey, cotangent, so find the tangent. So tangent is opposite over adjacent. And then you need to flip that. So instead of opposite over adjacent, you're going to do adjacent over. Oh, we don't have adjacent. So what do you do when you don't have a side? You need to use Pythagorean Theorem. So we're going to find a. So it's going to be a squared equals c squared, which is 8. That's your hypotenuse, minus b squared, which is that. So a squared equals 64 minus squaring this, you get 4 times 5, which is 20. A squared equals 44, square root of that. It's going to get you a equals the square root of 44. We can pull a 4 out of there. So a equals 2 times square root of 11. Square root of 4 is 2. That is a. 2 times square root of 11. So I'm running out of room. But to get the cotangent now, so you need opposite over adjacent. We're going to get opposite would be 2 times square root of 5 over 2 times square root of 11. Rationalize by multiplying by the square root of 11. And we're going to get 2 times square root of 55 over 2. Those 2's can cancel out. So square root of 55 is your ratio for the cotangent, square root of 55. And it went a little fast, and this is getting a little messy. So if you'd like to reset, rewind, pause, go for it. Secant is the inverse of cosine. So cosine is adjacent over hypotenuse. So we're going to get the square root, or 2 times square root of 11 over 8. Simplify that. Square root of 11 over 4. But that's not what we want. This would be cosine. That's adjacent over hypotenuse. I got to flip that. So really, this is 8 over 2 times square root of 11. I can simplify this and get 4 over square root of 11, but I got to rationalize square root of 11. And again, I'm sorry that I'm getting a little messy here. This paper is kind of giving me anxiety. So we get 4 times the square root of 11 divided by 11. That is your secant of theta. Okay, this is not a right triangle. And in fact, we've done this, I believe, so I'm going to make another one. So let's do A, B, C. Let's do 27 degrees. Let's do 25, and let's do 37. So we have to ask yourself, what do you have? Well, we have a pair. We have the angle side pair of C. So whenever you have a pair, that tells you that you should probably try to do law of sines. And the law of sines is used when you have non-right triangles and you need to find missing sides or angles. So we're going to do sine of C, which is 27 degrees, divided by the side C, which is 25, equals, we do not have the pair complete for A, so it's going to be sine of A divided by 37. So we're going to find angle A. From this point, it's time to solve. So we have to get A by itself, times by 37, and just rewrite this out. So 37 times sine of 27, all divided by 25, equals sine of A. To get rid of sine, you can't divide it. You have to take the inverse. So we're going to take sine inverse of the left-hand side. That's going to get rid of that. They're going to cancel each other out. You'll get just A. And then over here, we're going to put all of that into the inverse sine function. And that's going to go into your calculator to help you figure this out. Make sure you're in degree mode. So we're going to get inverse sine times 37 times sine of 27. I need to go back and add some parentheses just to make sure I get this right. So all in parentheses, 37 times sine of 27 divided by 25, close that parentheses. So all of that gets put in, and we should get our angle measure, which is 42.214. 42.21, 42.214, however you want to write that is good with me. So A equals 42.21 degrees. We'll just keep it simple for this one. So that's A. That's A. Now we can find the rest. The other angle, knowing that triangles have 180 degrees, you do 42.21 plus 27. Subtract that from 180. And you get 110, so B is 110.79 degrees. Now, because we have all the angles, we can just do the other ratio. So I would stick with the one that you started with, though. So sine of 27 over 25 equals, now we need to learn what little b is. So we're going to do sine of 110.79 divided by little b. And now we got to solve for this. So you can baby step it and multiply by b, and then do the inverse of sine. But I'll just do this. I will baby step it because to get ahead of myself, I got distracted, sorry. So b times the sine of 27 divided by 25 equals sine of 110.79. So we need to get b by itself. So we're going to go ahead and divide or multiply by the reciprocal, so 25 divided by sine of 27. Do that on both sides. Oh, I did it the wrong way. So this is just 25 over sine of 27. And then we're going to, this all cancels each other out. So then b equals sine of 110.79 times 25 divided by sine of 27. So carefully get all that in your calculator. I'll do the 25 divided by sine of 27 first. Looks, oh, that's like 55.06 da 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 times that by sine of 110.79. And our answer, 51.481, 51, you could round it to 51.482. So B equals 51.482 units, whatever that is, that's the length, that's the side length through B. So 25, 37, 51.482, that's your angle measures. That's how you use the law of sines. All right, guys, so that's the review. That's the review packet. Use it to help you get yours done. I can go over other stuff. Let me know what you need. For finals, guys, it's everything we've been doing. The best thing you can do is just take the time and do the math, not just look at the math. And I think you guys will be straight. Let me know what else you need. Subscribe, comment if you need something. Share this with your friends. I know you guys got people that need some help in math. I'm always willing to help everybody out. Mr. Answer 414. See y'all later.